So here we have our first, it's a bonus stop, and there's the bridge that we used to use, except it's not where it used to be. We're still about a quarter-mile hike downstream from where the bridge used to be, and you can see the power of the storm that moved this not at all insubstantial bridge. So the power of Mother Nature. Okay, so bonus stop. So we are actually here looking at one of the rocks that we'll be talking about a little bit later in the trip. This is the Palms Formation, the Palms Quartzite. If you look closely at it, you should see some bedding planes, kind of wiggly waggly bedding planes in here. Okay, this is a metamorphosed rock. It's a metamorphosed sedimentary rock. It's roughly called a quartzite. So it's sort of a metamorphosed sandstone, kind of a muddy sandstone that's been metamorphosed. So more on this later. But this is the layer that actually sits on top of the rock that we're going to be looking at on this stop. So take this as a bonus stop. Very cool, very, very cool bridge on very old rocks. Okay, as I promised, a little bit more at this site of the wrecked bridge sitting on the Palms Formation. So here we see, once again, some of these sedimentary rocks. This is the Palms Formation, an argillicious sandstone metamorphosed to something of a quartzite. There's a number of sedimentary features to point out here to recognize. So first off, we see still some of the original sedimentary features. Now, some of these are overprinted with metamorphic foliations, but some of the you're seeing here are remnants of the original crossbeds here. So that's a sedimentary indicator, tells us something about the environment, which we'll be talking more about. But there's those there. There's some in here that are a little bit harder to see, that have been a little bit more messed up by some of the metamorphism. You also notice here that these rocks are pretty steeply dipping. So if we take our little compass here, and let's see, where's a good spot? Right here, and if we take a look at this, we align our compass, and we get a sense of what it is. You'll see that these rocks are dipping at about 40 degrees, which is a little bit shallower than some of the other rocks in this region, as we saw based on what we saw at Copper Falls. But this is an argillicious sandstone. So you see variable stratigraphy. Some areas are pretty light colored. Other areas are a little bit more purple. So this is the Palms Formation. And again, we'll see this at another stop where it bleeds into the Ironwood Formation. Okay, so these rocks sit non-conformably above the Bad River Dolostone. All right, the beautiful Marengo River. I'm wishing I had my fishing pole. Okay, here we are. We are on Lake Road, a little bit west, I'm sorry, rather a little bit east of Mellon, the booming metropolis. Little gravel road. Up ahead are some nice rocks. Let's go take a look. Okay, so where we came from. Got another car. It's a roadside stop. Adventure dog Ida is going to stay in the car for this stop. And look ahead. Look, there's some nice outcropping of rock. All right. Let's take a look. Okay, so here we are on Lake Road, looking up close at these rocks. Okay, we're going to start by just kind of walking up and down the road and seeing what we see, and then we'll come back and take a closer look at these. We should be noticing once again that these rocks are pretty steeply dipping. I'm going to try to take another measurement there. Okay. So the outcrop kind of peters out here, but it picks up again here. It's pretty similar. We're seeing some layering, some kind of purples and grays, some black. Looking a little different here. Keep keep going and seeing how things look. Some more rock hiding in the bushes over there. Little creek running through here. Okay, so now we're back at the bottom, if you will, of this outcrop. Let's take a closer look. Let's get across, see how wet this little ditch is here. Let's take a look over here. It's a nice little spot to look. Okay. You see some nicely laminated, fairly finely laminated, but it's variable. Sort of darker and laminated here, gets into a little bit more browner, a bit more massive in this stretch, before alternating back to a little bit more finely laminated. Okay, and then going along further. So these rocks are more, they might look familiar. This is actually more of the Palms Formation. Okay, this is the same rock that we saw as we were hiking back in to find the Bad River Dolostone. Okay, it looks a little bit different here. So what we saw at the Bad River Dolostone spot was the stratigraphic bottom. So that would have been the very oldest of the Palms Formation, the stuff that was sitting right on top of the Bad River Dolostone, non-conformably. And here we see the top of that stratigraphic unit, this top of the Palms Formation, up ahead grading into a different kind of rock, our next rock type. So we'll talk about that in a moment. Okay, let's talk about another measurement we can make here looking at the Palms Formation. We can take a strike and dip. These are actually really, these rocks are nicely oriented to take some strike and dip measurements here. So take a look at our compass. So here's our compass, and there's a couple things that we can do with this compass. The first thing we can do is just take a measurement. And so to take a strike, what we're going to do is we're going to measure the intersection of the horizontal plane, okay, which in this case will just be the compass. So I'm just going to try to hold it horizontally, and where that horizontal plane intersects with the plane of the dipping rocks. Okay, so assuming I'm holding that horizontally, we're looking at this here. Now we're going to move this, put the red in the shed, as they say. Okay, and we'll hold that steady. And if we look at this, okay, you'll notice that the measurement here is about, 75 degrees east of north, or about 255 degrees. So that's nearly east-west. So that is the strike measurement. Okay, so that means these rocks are striking at nearly east-west. Okay. And the measurement specifically is, right here, if we had to call that, we'd say at about 75 degrees east of north. All right. And then we can turn that around and we can measure a dip measurement here. Okay. And we'll do that in 1 second. Okay, so to take a dip measurement on this with this compass, what we're going to do is we're going to start by taking the compass and we're going to align it so the east-west measurement aligns with the with these little glow-in-the-dark little highlighted spots. Okay, so it's going to be oriented like this. Okay, and then what we can do is we can take that and we'll put it against that rock and we'll look at this little clinometer down here. Oops, let's turn it around and measure it from this way where there's the numbers. Okay, and we look in the clinometer and you'll notice that right there is what it's pointing to, and that would suggest that it is dipping at about 60 degrees. That's about the same. I think it's a little steeper dip than what we saw near the Bad River Dolostone, but that's a dip of about 60 degrees, and it's dipping nearly to the north. Okay, so the dip is in a northerly direction. You remember that the strike was striking nearly east-west, and the dip is always going to be perpendicular to the strike, and that means that these rocks are dipping into the ground to the north at about 60 degrees. Okay, so let's talk a little bit more about the Palms Formation here. One of the other tools that we can use to investigate these mineralogically is this, and this is a little magnet. Here's another one. Okay, so these are both magnets, and what you can do with these, well, let's start with this guy. And as you touch this, nothing Nothing is particularly magnetic. So that's, you know, if we're talking just about a quartzite, that's not necessarily surprising. This is magnet's a little bit more sensitive. You can see a little bit, maybe slightly magnetic here in this massive part. Okay, moving it along. When it gets into this finely laminated stuff, let's see, is it any different? Maybe slightly more magnetic. You see how that magnet kind of drags across the surface, is attracted to the rock. So that would suggest that these rocks contain at least a little bit of magnetite, which isn't terribly surprising. Even today, it's not uncommon to find little bits of black magnetite in sandy deposits. So the Palms quartzite here would have been deposited. It's interpreted as being deposited in, it's an argillicious sandstone, so sort of a combination of sands and muds, sort of sands and clays. With alternating layers. Some of these places where it's more finely laminated probably represent a little bit calmer water environment with more clays depositing. Some of the more massive sections might have been some coarser deposits that were a little bit sandier. We'll collect a few samples from here, as well as some samples. We collected some samples from the other location of the Palms Formation. It might be interesting to compare the different types of the Palms Formation, both the different, you know, sort of interbedded units of the fine and the coarser stuff, as well as the stratigraphic bottom, which we saw closer to the Bad River Dolostone, and now the stratigraphic top of this same formation. Okay, so here we are looking at the Palms. So the next unit up, the next unit younger, should be further to the north, since these rocks are dipping to the north. And so as we're walking stratigraphically younger, so as we walk along here, we're looking at progressively younger rocks. There's a little gap in the outcrop. Let's see here. This looks like more of the same, some of that kind of purplish, gray, light-colored, massive. This is more of the Palms Formation. You look in there, once again, some alternating bands, some finely laminated, some a bit more coarse. Okay, walking along here. This looks a little different here. Let's get up close and see if we can notice anything different. Okay, this looks like a little darker, finely laminated. Let's see. Maybe slightly magnetic in some of these coarse zones. Use this one here. Not particularly magnetic. Again, that layer's got some magnetite crystals. Not much different here. So I think this part of the outcrop is still in the Palms formation. Let's keep walking down the road. Going down. There was a soundtrack for this stop. I feel like maybe it should be some John Denver, maybe. Doo-doo-doo, walking down the road. Doo-doo-doo-doo-doo. More rocks. All right, so after this little gap, looks like we've got another outcrop here. And let's see what we've got. Let's see what we've got here. This rock looks kind of different. This rock looks a little bit more black and massive. Now let's see. Yeah, here we are. Okay, and if you look up close, you can see some spots with this nice, wonderful, distinctive red color. So once again, kind of dark and some laminated. But let's check out the magnetism here. Oh yeah. Oh boy, look at this. Okay. Okay, so this is clearly quite magnetic, okay, which means we are now here into the Banded Iron Formation. This is the Ironwood Iron Formation, and so as we walked along Lake Road, we have crossed the boundary from the Palms Formation into the Ironwood Formation. And this is a conformable sedimentary boundary, which means that the palms just grades, the environment changed and the depositional environment changed to go from depositing the argillaceous kind of quartz, clays, sandy stone into this iron stone. Okay, we'll see a lot more of this iron formation, the Ironwood Iron Formation, when we go up to the top of Mount Whittlesea in a little bit. But what we notice here is it's magnetic. It's mostly kind of this black colored with some bands of sort of this more reddish. This section right here, you know, has some spots that are pretty finely laminated, other parts that are a bit more massive. Like I said, we'll see a lot more of this when we get to the top of Mount Whittlesea. Here we are looking a little bit at the ironwood. I'm going to collect some samples. These are going to be some samples that you all are going to have. This is clearly a spot that geologists have sampled before, and some poor geologist even lost her chisel here. So got some rocks. I'm going to collect a few more. Just pound on this. A couple of these nice pieces here. So this banded iron formation here it's not slate, but it almost looks like the rock slate. And the iron formation in this region has been kind of lumped into two categories, sometimes called slaty, where you see this almost slaty looking cleavage, and then other places where it's a little bit more massive, sometimes it's called cherty. This over here looks a little bit more cherty, but we'll see better differentiation of those two types of iron formation when we get to the top of Mount Whittlesea. So when you look at some samples from near the contact of the Palms Formation, this is where they're being collected from, right here. Okay, so I've collected some samples here. We're in the Ironwood Formation. Samples for you guys to take a look at. So this is the Ironwood. So again, these rocks are dipping to the north, okay? Our next stop, we're going to drive further to the north. We're going to hit State Highway 77, and which will give us the next rock unit younger than the Ironwood Formation, if these are continuing in the same sort of stratigraphic orientation of this east-west strike with a steep northerly dip. Okay, here we are at our next stop. We've traveled probably about 10 miles or so from our last stop. We traveled a little bit further north on Lake Road, about a mile on Lake Road, and then we've been going straight east on State Highway 77. So if you think about that in terms of strike and dip orientations, we went up dip, or down dip I should say, no, up dip for about a mile, getting us into some younger rocks, and then we've been traveling along strike, traveling east, which is the direction of the strike, to get to this next rock, which we see a nice outcrop of here. Lots of piles of this stuff, kind of dark colored, okay, mostly dark colored, but some rusty stains, okay. And this looks like slate, because it is slate, okay. So this is a slate, which was originally a shale. Okay, and this is the Tyler Formation, okay? These sections that are a little rusty colored, I like to call Rusty Tyler. Sort of a Rusty Tyler. Sounds like a baseball player, okay? So here we are at the Rusty Tyler. I'll collect some samples of this. Notice very finely laminated, slaty cleavage, okay? I'll take a strike and dip measurement here as well. We'll collect a few samples to share with you all, okay? But this is the Tyler Formation, okay? This is the youngest of the sequence of conformable units going from the Palms Formation into the Ironwood, into the Tyler, all conformably. The Tyler is quite thick relative to the other two, especially relative to the Ironwood.